about continuing our conversation with Dr. Stover, get a little bit more into the benefits of the nuclear sector and domestic energy supply and mining. One thing I don't understand, which I hope you can explain to me, is what is a small nuclear reactor? Like I keep hearing about them, I read about them, but is it basically a small plant that can power a community as opposed to something a city? Like, what is it?
Well, there's you're first of all, it's the product of continued advances in nuclear power technologies, and the concept is, in fact, as you say, a smaller generating facility that can power local areas rather than trying to do large regional areas. The other thing, the key to it is the hope. The intent is that this be a design and a type of reactor that can be built in a factory, in a standardized factory constructed unit that can then be moved to various locations. On top of it, it's worth noting that not only is the U.S. Department of Energy strong proponents of this development, but the U.S. Department of Defense is also extremely interested in seeing this development for military applications with our remote military bases around the world. I've been told that in the Middle East in particular, a large number of the U.S. military casualties were related to convoys transporting fuel to these remote locations. There's a vulnerability there that can be eliminated if you can place a small modular reactor at one of these facilities to provide the necessary power or electricity to operate the whole base.
Interesting. I hadn't even thought about that. So with the small nuclear reactors, is one of the intents that you almost get like a Ford assembly line type of production where you've got consistent designs and consistent parts, so you can basically mass produce as opposed to having a larger, uniquely designed facilities? Am I getting that?
I that's the intent.
Okay.
And let's say that's the hope as well. It still comes down to getting regulatory agencies to really sign on to a truly standardized design that can be repeated, and at the same time getting the customer, whether it be a community or a utility, to accept the fact that they will get a standardized design. They can't be customizing it for this particular location. They have to modify the location to accommodate the standardized design.
Interesting. So just like McDonald's, when you go into McDonald's, your Big Mac's going to be the same no matter where you go.
Exactly. And the
that makes it
look the same too.
Okay. And that makes it more streamlined for the regulatory process.
Not only that, it has a tremendous impact on the front end capital requirements as well, and the time involved. Again, if you've got something being standardized, they're all built the same, and if it comes out of the factory, that's quite different from all these custom designs that have characterized the large nuclear power plants that are now in service.
Yeah. And I don't think there's an understanding of how advanced and how highly regulated the nuclear industry is over the past 50 years, the changes that have been, and often people's perceptions are based on very old information, but there's been massive and significant safety and environmental, everything's changed over the past 50 years.
Yeah, that's absolutely the case with uranium mining, whether it be conventional or ISR. There's been in the Cold War era of the 1950s and the 1960s, the focus was on national defense. That was really the main purpose for mining uranium up until the advent of the nuclear electricity era in the which began really in the late 60s and up through the 70s. And as a result, there was a lack of information and a lack of understanding about the safety standards and the health risks that conventional miners might be exposed to, again, in the 1950s and maybe up into the early 1970s. But there were dramatic changes, both in terms of the understanding of health physics and in the enhanced, as a result, then improved regulations, and particularly on the safety side. No question, uranium mining in the United States is part of, as you say, is part of the nuclear fuel cycle, and it is by far and away the most heavily regulated business in the United States, and certainly the most heavily regulated mining industry in the United States.
Yeah. So you came into mining, and this is a question I always ask people. So you came into mining through oil and gas.
Yes.
So you're a chemical engineer by education, PhD. So you, I guess, were in the mining industry before you realized you were in the mining industry.
Well, as I said earlier, this is in situ recovery is a multidisciplined area. I don't think of myself as a conventional miner. I don't dig dirt. But it was an evolutionary process. I took on an R&D assignment at Atlantic Richfield and got an opportunity a very rare opportunity for someone working in research to be involved in a relatively short period of time with a pilot plant development and then a commercial development, and working out hands-on in the field with these people, putting these things together and operating them. I got spoiled. I was not going back to hydrocarbon research. I wanted to stay out there with a hands-on situation. So, and I've been very fortunate over the years. Starting out with Atlantic Richfield, I went from there to a very small company, and Everest Minerals, and then later on to Real Alga Mining Corp, a large international mining company, and then, of course, with Energy Metals, and then back to a large company with Uranium One, and now back to a small company with Encore Energy Corp. It's been an amazing career, and I've learned a great deal of going between small companies, startup companies, and large established companies. It's fascinating.
And you're still learning.
Oh, absolutely.
Yeah.
We joke about it around here as someday I'm going to figure out what I want to do when I grow up.
Because we haven't even talked about Group 11 and what you're doing there to look at how to apply ISR to other metals.
Oh yeah, this is absolutely an exciting time, and with Group 11, we're really now taking a real serious look at being able to apply alternative ISR processes to the mining and recovery of gold, as well as potentially other minerals of value. In the case of gold, we're looking for alternatives to the use of cyanide, and we certainly are at this point very much aware and very comfortable with the alternate chemistry that we've have access to, and it's very benign. It uses everything that's again, it's like ISR with uranium. It's a benign thing, and it doesn't have the environmental upsets and impacts, and certainly not the concern about the leaching fluids being used. Everything we do can be restored and reclaimed. But like any ISR project, and we are limited into what kind of uranium, what kind of mineral deposits we can look at. They have to be ones that are amenable to fluid flow, and we have to be able to flow fluid through the deposit. We have to be able to bring that fluid in contact with the mineral we're trying to dissolve and put into solution and get it out of the ground. In many cases,
and control where the fluids are going.
The fluid, So in many cases, we're working below the water table, particularly in the case of uranium, because we've got hydrologic control, but there's other means of control as well that we should allow us to extend it to deposits that are in dry zones as well. But the biggest thing is being able to get that fluid, that lixiviant or leaching fluid, into direct contact with the mineral so that we can dissolve it and put it into solution. There are deposits where the target mineral, whether it be uranium, gold, or copper, or whatever, may be encased in clay or maybe encased in shale, where we can't get that direct fluid contact. And so those kind of deposits are not going to be amenable to in situ recovery per se. And it may just be that those are only amenable to conventional mining. And that's just the nature of the world, I guess, in that respect.
Yeah, yeah. So I want to talk for a little bit about the importance, and we'll just refer to the extraction industry
Okay.
to include hydrocarbons, gold, uranium, mining. The importance of a domestic extraction industry, because in my adult life, I've watched everything move offshore, and for the benefit of the environment, and we just don't see it. We don't like it in our backyard is really the message, but we like the benefits of it. So the importance of a domestic extraction sector.
Well, several points, but the first one, your point about the environment. Everyone needs to appreciate that the United States has the most stringent environmental requirements placed on all mining and all mineral extraction, including oil and gas. Our regulations, our restrictions are far more severe than anything you see in the undeveloped countries, anything you see in Asia or Eastern Europe. If you want a safe environmentally sound method for extraction, you're going to find it in the United States. The other thing, a key thing that's come home now, particularly with the situation in Ukraine, is the uranium industry in particular, but we certainly are not alone in this situation, has become almost totally dependent on Russia and a number of its former satellite countries for the production and the processing of the first front end of the nuclear fuel cycle. And that's particularly true when we talk about the emergence of the small modular reactors, because they run on a more highly enriched quality of uranium than the existing reactors. And right now, the primary source for that material is Russia. And it's because they, as state-owned entities, have been able to manipulate the market, depress the prices below what's really an economic break-even point, even for most of the Western world in terms of uranium mining. But having said all that, it's equally valid when we talk about wind power, solar panel. We're dependent on China in particular for most of our solar panels, many of our the components that go into it, many of the minerals that are essential for the construction of wind turbines are coming from China, the rare earths in particular, and we depend on the Belgian on the Congo for cobalt, and the fact that they make extensive use of child labor in very unsound methods. We're extremely dependent on the source of the metals, and particularly the metals that are necessary for the construction of wind turbines and the generators that are involved in those turbines. That's just the reality of it, and we put ourselves in that position, unfortunately, and we really need to be more conscious of that and making a more concerted effort to develop sources, particularly domestically, to enhance our own national security.
Yeah.
and our own
Yeah. No,
ability to have clean energy.
yeah, no different than watching all the manufacturing leave the country. You can't have an economy that's based for, I guess you can, as long as you're the world's global currency, based around the financial impact of the dollar. But at some point, you need to pull this stuff back. And I'm hoping that this is the beginning of it, because it's I've had the benefit of being in an industry town and seeing what it's like with 100% private sector employment, not
Mhm.
just 100% employment, but all related to the fact that there's this economic engine that's driving the whole region and the wealth that's created. I think the mining industry has had a policy of keeping its head down, just staying out of sight, in order to keep moving. But I think self-promotion is important right now.
Yeah. Well, there's no question that the mining industry has perhaps not been the best salesman of their promoter of their own social economic benefits that they provide not only to the local communities but to the country as a whole.
Yeah.
And for whatever reason, it's not a new phenomenon. It's as long as I've been associated with some aspects of mining, I've been very much aware of that.
Yeah. Yeah.
And
And it's, nothing's perfect, but I think it's the best sector there is. The collective extraction industry, and it drives and creates the wealth that comes from all of the downstream benefits from it.
yeah,
And it's not the same industry that it was 50, 60 years ago, 100 years ago. And yeah, you're right, has to do better self-promotion.
well,
Um,
one of the things that gets overlooked, and one of the mining associations many years ago had a bumper sticker that said, "If you can't grow it, you've got to mine it." And in reality, that is the truth. And
yeah,
of course, and it's really extraction industry, what you're talking, making use of the subsurface and surface minerals that are there and
yeah,
assets that we have.
yeah, yeah. It is an asset, and it was placed there for a reason.
Yep.
Um, I also really feel that the industry creates a lot of talent, and it's all transferable skills. When you are a metallurgist or a fabricator or an accountant, you may learn in that industry, but you're taking it elsewhere, and the impact that you can have from highly educated employment is phenomenal, just like
Mhm.
yourself.
Well, it's also true of the plant operators and the skills that we need at that in this digital age. Where there's very much a real need and opportunity for people that have been through have an associate's degree or have been through some of the training programs. We need electricians and plumbers and all kinds of people like that, just as much as any other industry does. And the opportunities are there.
And the thing and educate me a bit more on this, but in situ recovery technology, those are some very skilled jobs that you're creating.
They they are, and particularly the need for, as you were alluding to, engineers and geologists in particular, but also, in the operations of the facilities, we need people that are technically savvy. They don't have to be experts in writing software code or something like that, but they need to be um, comfortable with operating with modern technology and even in running the plants and stuff, because we're like every other industry
Yeah,
moving towards more automation and more control.
yeah, and electronic monitoring, everything, right?
Yep,
Well,
absolutely.
Dennis, yeah, I did that again, Dr. Stover. Sorry, my informality. I really enjoyed talking. I want to get you back, and we're going to talk another time about Group 11.
Sounds good.
And yeah, I love your Michigan football there. We talked about it before we started filming. So you're a huge um, alumni fan, and I think you go to every game, don't you?
Well, we have season tickets, but unfortunately anymore we do well if we get there for 2 or 3 games. But we have a lot of family, both my wife and I, we have a lot of family still in Michigan, and there's a long line for family tickets. We never have any shortage of volunteers to take our seat.
So the blood runs blue.
Yeah, my side of the family anyway. On the other side, it may run a little bit, be tainted by a little bit of Notre Dame enthusiasm, but
Okay.
I tolerate that.
Oh, good. Well, on my family, on my husband's side, Bill quite well. He's a UTEP, but his dad was Oklahoma.
Yes,
So we are true blue Oklahoma fans. So we're
I
and,
understand
and
that. I'm well aware.
well, thank you so much, Dr. Stover, of infamy in the field of in situ recovery. Thank you again.
You're welcome. And it's always a pleasure to have a chance to visit and talk a little bit about ISR and its role in helping develop clean energy and supply the future in nuclear.
Perfect. Thank you so much.
Thank you.